Hello everyone, today we are gonna talk about prime numbers. I think most people know what a prime number is, but I want to re-mention the definition of primes. So the definition of primes is an integer p bigger than 1. We always denote the letter p as primes. An integer p bigger than 1 is called primes if the only divisor of p is plus or minus 1 and plus or minus p. So for example, let's say 5 only has a divisor of plus or minus 1 and plus or minus 5, so that's a prime number. But for 6, it has plus or minus 1, plus or minus 6, plus or minus 2, plus or minus 3, so this is not a prime number. So that's basically the only definition in primes. Therefore, we are more focusing on the questions for prime numbers. Let's just move on to the questions. So for the first question, prove any integer a bigger than 1 has at least one prime divisor. So this is asking that whether an integer a only has a composite divisor. So for composite numbers, these are numbers that are not primes. If a number is a prime, then it is not a composite. If a number is a composite, then it is not a prime. So let's prove it. First, let's let p be the smallest prime divisor of a. Then p divides a. However, can p be a composite number? So if p has a prime divisor, let's say q, then q divides p, and so that q divides a. However, q is less than p, less than a, so p is not the smallest prime divisor. So this is a contradiction. So p must be the smallest prime divisor. So every integer, for every positive integer a, it has a prime divisor. Now let's move on to the next question. Let p be a prime. Find all positive integer x and y such that 1 over x minus 1 over y equals to 1 over p. So when we first saw this form, it is hard to see any properties inside the fraction. So let's cancel the fraction by times xyp on both sides. Proof. So xyp times 1 over x equals to yp, and xyp times 1 over y equals xp, yp minus xp equals to xyp times 1 over p equals xy. Thus, p times 1 y minus x equals to xy. This follows that p divides x or p divides y. In the first case, p divides x. So let's let x equals to p times x1 for some number x, x1. Then p times y minus p times x1 equals to p times x1 times y. You can cancel p on both sides, and this becomes y minus p times x1 equals to x1y. Y equals to x1y plus p times x1. However, you see that x1 is definitely a positive integer, so x1y is definitely bigger than y, so this cannot be happen. And this is a contradiction. So p cannot divide x. Now let's move on to p divides y. So if p divides y, let's let y equals to p times y1, and let's see this equation. So p times y1 minus x equals to x times p times y1. We cancel p on both sides, then p times y1 minus x equals to x times y1, and p times y1 equals to x times y1 plus x. This is x times y1 plus 1. Thus, p must divide x, or p must divide y1 plus 1. However, we just proved that p cannot divide x, so p must divide y1 plus 1. Let's keep doing that. So let's make y1 plus 1 equals to, let's say, kp. y1 plus 1 equals kp. Then let's see this equation, which is p times y1 equals to x times y1 plus 1. We can substitute y1 plus 1 as kp, then kpx equals to p times y1. So we can cancel p on both sides. y1 equals to kx. As we have y1 equals kx, we can substitute y1 into this equation. So p times kx minus x equals to x times kx. P times k times x equals to, this is kx squared, so kx squared plus x. We can cancel x on both sides. pk equals to kx plus 1. So right now you see k divides kx, so k must divide 1. Thus, the only number for k is k equals to 1. Now we have y1 plus 1 equals to p, so p equals to y1 plus 1. But y equals to p times y1, so y equals to p times y1, where y1 equals to p minus 1. So equals to y is thus equals to p times p minus 1. Now we have a function for y. So we need to find x. We have y1 equals to kx. When k equals 1, then y1 equals to x, and y1 is p minus 1. So x equals to p minus 1. Now we solve the question. For any primes p, we have the form of x equals to p minus 1, and form of y equals to p times p minus 1. Next, I'm going to introduce a theorem. It is called the fundamental theorem of arithmetic. This theorem is very important. Its definition is that for any integer n bigger than 1, n can be written by a product of primes. This means that n equals to p1 times p2 times p3, blah blah blah. For any integer n can be written as this. So let's move on to the questions.